Hello everyone and welcome to another exciting video on cybersecurity by Edureka. In today's video, we will dive deep into CSRF attacks, also known as cross-site request forgery, one of the sneakiest vulnerabilities in the world of web applications. We will uncover how these attacks work, the potential risks they pose, and most importantly, how you can defend against them to keep your applications safe and secure. So, whether you are a cybersecurity enthusiast, a developer, or just someone curious about how hackers exploit web vulnerabilities, stay tuned because this video has something valuable for everyone. Before we dive in, let's quickly look at what we will be covering in this video. First, we will explore Introduction to CSRF. In this section, we will explore what cross-site request forgery is and how it can become a dangerous vulnerability for web applications. Next, we have cross-site scripting versus cross-site request forgery. In this section, we will highlight the key differences between CSRF and cross-site scripting, including their scope of impact, attack types, and severity. Then, the impact of CSRF attack. Here, we will discuss the potential consequences of a successful CSRF attack, including the risk to user data and the complete compromise of user accounts. Next, we will move on to how does CSRF work. Here, we will break down the mechanics of a CSRF attack, covering the essential conditions that must be in place for the attacks to be successful. Then comes how to deliver a CSRF exploit. Here, we will go over the various methods an attacker may use to deliver a CSRF exploit, whether through external websites or direct malicious links. Next, exploiting CSRF vulnerabilities. In this section, we will walk through a live demonstration of a CSRF attack using the DAM vulnerable web application, a purposeful vulnerable web application designed to help us practice and understand web security flaws. We will also show the setup process for this demo to ensure you can replicate it on your own. Finally, common defenses against CSRF. Here, we will highlight the best practices and defenses available to prevent CSRF attacks, such as using CSRF tokens, same-site cookies, and referral-based validation. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon for the latest tech content from Edureka. Also, visit the Edureka website for various training and certification courses. The link to the website is in the description box below. Alright, let's kick things off by understanding what CSRF is and why it's such a dangerous vulnerability in web applications. Well, cross-site request forgery, also known as CSRF, is a web security vulnerability that allows an attacker to induce users to perform actions that they do not intend to perform. It allows an attacker to partly circumvent the same origin policy, which is designed to prevent different websites from interfering with each other. Now, to really understand the severity of CSRF, let's look at the real-world example. In 2015, a vulnerability was discovered in the popular web app X, which allowed attackers to use CSRF to perform unauthorized actions on user accounts, such as transferring money or changing account settings. These kinds of attacks highlight just how serious CSRF can be when not properly mitigated. A successful CSRF exploit in this case would give an attacker full control over the victim's actions without them even knowing it. Now, let's compare CSRF with another commonly discussed vulnerability, cross-site scripting or XSS. While they sound similar, they work in very different ways. Well, cross-site scripting allows an attacker to execute arbitrary JavaScript within the browser of a victim user. This can lead to the attacker stealing cookies, session tokens, or even performing actions on behalf of the victim. And on the other hand, cross-site request forgery allows an attacker to trick a victim user into performing actions they didn't intend to, like submitting a form or changing account settings, all without the user knowing. Now, let's talk about the key differences between CSRF and XSS. First, if we talk about the scope of impact, XSS is generally more dangerous than CSRF because it allows attackers to perform any actions the victim can do, while CSRF typically affects only specific actions that the user is authorized for. And another thing is that CSRF is a one-way attack where the attackers can make the victim send a request but cannot access the response. Whereas the XSS is two-way, meaning the attacker can inject scripts and capture the responses, making it more versatile and dangerous. Now to summarize, XSS provides broader attack potential, whereas CSRF is more limited but still risky if not properly defended against. Now that we know the basics of CSRF, so let's take a closer look at what can happen when this vulnerability is exploited successfully. In a successful CSRF attack, the attacker causes the victim user to act unintentionally. Like for example, this might be to change the email addresses of the bank account or to make a funds transfer. So depending on the nature of the action, the attacker might be able to gain full control over the user's account. If the compromised user has a privileged role within the application, then the attacker might be able to take full control of all the application's data and functionality. So now we know the potential damage a CSRF attack can cause. Let's move on to how these attacks actually work. For a CSRF attack to be possible, 3 key conditions must be in place. First, a relevant action. There is an action within the application that the attacker has a reason to induce. This might be a privilege action such as modifying permissions for other users or any action on a user-specific data such as changing the user's own password. Next comes the cookies-based session handling. Here, performing the action involves issuing one or more HTTP requests, and the application relies mainly on session cookies to identify the user who has made the request. There is no other mechanism in place for tracking sessions or validating user requests. Next comes the no unpredictable request parameters. The requests that perform the action do not contain any parameters whose values the attackers cannot determine or guess. For example, when causing a user to change their password, the function is not vulnerable if an attacker needs to know the value of the existing password. Alright, let's take a look at how a CSRF attack works with an example. So imagine there's an application that lets a user change their email address. Here's the request that the app might send when the user tries to update their email. Now, this request meets all the conditions for a CSRF attack. Here, the action, changing the email address, is something an attacker would want to perform. Next, the app uses a session cookies to identify the user without any additional tokens or checks to secure the session. Then, the attacker can easily guess the values needed for this request. And with this condition in place, the attackers can construct a web page containing the following HTML code. So, when a victim visits the page, the following happens. First, the page triggers the HTTP request to the vulnerable website. Then, if the victim is logged in, their browser automatically includes their session cookie in the request. Next, the vulnerable website processes the request as it came from the victim, and it changes their email address without them even knowing. And this is where the malicious script automatically submits the form once the victim visits the page, triggering the attack. So one thing to remember here is, although CSRF is normally described in a relation to cookie-based session handling, it also arises in other contexts where the application automatically adds some user credentials to request, such as HTTP basic authentication and certificate-based authentication. So now that we have outlined the key conditions for a CSRF attack, so let's look at how these exploits are actually delivered to victims. So the delivery mechanisms for cross-site request forgery attacks are essential for the same as for reflected cross-site scripting. Typically, the attacker will place the malicious HTML onto the website that they control and then induce victims to visit that website. This might be done by feeding the user a link to the website via an email or social media message. Or if the attack is placed into a popular website, they may just wait for the users to visit the website. Now that we have covered how CSRF exploits are delivered to victims, so let's dive into a live demonstration where we will exploit a CSRF vulnerabilities in DVWA, showing you the entire process from setup to execution. In this demo, we will set up DVWA on both Parrot OS, which will be our attacker machine, and Ubuntu, which is our victim machine. Then perform a CSRF attack to change the password on the victim's DVWA account. So in step 1, let us set up DVWA on Parrot OS, which is an attacker machine. So let's walk through setting up Damn Vulnerable Web Application or DVWA on Parrot OS. DVWA is a fantastic tool for practicing web application security. So before we start, ensure Parrot OS is updated. So for that, type this command. So this keeps your system ready for any installation. Now, DVWA requires Apache, MySQL and PHP. So run the following command to install them. So this setups your web server and database. Next, you need to start the necessary services such as Apache and MySQL. So for Apache, write this command. Well, and for MySQL, you can write this command. Alright. So you can also enable them to start automatically on boot using the enable option. Next, you need to log into MySQL using this command. So once this is done, let's set up the database and user for DVWA in MySQL. First, let's create a database for DVWA. So type create database DVWA and then press enter. So this command creates a new database named DVWA, where DVWA will store all its data in this database. Next, we will create a user for DVWA. So type create user and inside the single quotes, type DVWA_user at localhost and then followed by identified by root. And now press enter. Here, we are creating a new MySQL user named DVWA user who will only be able to access the database from the local host. So we also set the password for this user as root. You can also change this password to something more secure if you would like. But for now, we are using root for simplicity. Now, let's give the new user permission to access and manage the DVWA database. So for that, type grant all privileges on DVWA and after full stop give *2 and using single quotes write DVWA_user at localhost and press enter. Alright, so this command grants DVWA user all privileges on the DVWA database. This means they can read, write and modify data within the database. Finally, we will apply the changes to MySQL's user privileges. So for that, type flush privileges and press enter. Here, the flush privileges command refreshes MySQL's internal memory, so it recognizes the changes we have made to the user permissions. So without this, MySQL won't apply the new user privileges. So next, we need to download DVWA from its official GitHub repository. For this, go to the browser. So here let us type DVWA and click on the first link. As you can see on the screen, you have the code button over here. So let's click on it. So from here, copy this link. Let's go back to our terminal and here we will clone this repository. So for that, type git clone and paste the link here. So followed by this link, we will specify the web server directory where we want to store DVWA. So as you can see, we were denied. So make sure you have the root permission, else you will get an error saying permission denied. And this places DVWA in the web server directory. So first, rename the sample configuration file and then navigate to the DVWA configuration directory. So for that, let us type the command. So this is the command. And then we will change the extension of the config file to .php. So for that, type this command. Now, we will edit the DVWA configuration file. So for that, we will open it with Nano Editor. Now, as you scroll down, we will change some configuration. So here we are going to configure three things. That is, first we need to change the username to DVWA user. And then we will change password to root. And finally, we will make sure our database name is DVWA. Okay, now let us save this. Now, we need to set proper permissions for the DVWA directory. So for that, let us type the command. So this is the command. Okay, so this ensures Apache has access to DVWA files. And next we will restart Apache. So for that, let us type the command. Alright, so once this is done, now Open your browser and go to http localhost dvwa. And here, log in with the default credentials, that is username as admin and password as password. After logging in, you will see the DVWA dashboard, and to finalize the setup, go to the setup page and click on the create or reset database button, and this initializes the database for DVWA. And once the database is reset, log in again using the same default credentials, that is username as admin and password to be as password. And that's it. Your DVWA is now ready to start experimenting with CSRF vulnerabilities. And step 2 is set up DVWA on Ubuntu machine, which is our victim machine. Now to set up DVWA on your Ubuntu machine, follow the same steps we just covered for Parrot OS. So here the installation and configuration process is identical, so you can easily replicate the setup on Ubuntu. So once you have set up DVWA on both the attacker and victim machines, we can proceed with the demonstration. Now, let us move on to step 3, performing the CSRF attack on Parrot OS. First, make sure to set up the DVWA security to low. Now, go to the CSRF tab. After logging in, navigate to the CSRF section on the DVWA portal and then change the password to Edureka. And in the CSRF section, change the password to Edureka and submit the form. So once the confirmation message appears that the password has been changed, note the URL displayed in your browser's address bar. Copy the URL where the password change has been confirmed and paste it into the text file or notepad for the later use. Now, moving on to the step 4. Execute the CSRF attack on Ubuntu machine. First thing is to make sure to change the DVWA security to low. Then, navigate to the CSRF tab on Ubuntu. And in the CSRF section on the Ubuntu machine, paste the malicious URL which you copied earlier from the Parrot OS into the browser's address bar. So after pasting the URL and pressing enter, you should see a password change confirmation on the Ubuntu machine as well. Next, to confirm the password change, click on test credential and enter the new password Edureka. And here, if the login is successful, it confirms that the password has been changed on the victim's DVWA portal. Well, this demo shows how an attacker can change the password of another user without their knowledge simply by exploiting a CSRF vulnerabilities. So by manipulating the victim's browser, an attacker can perform unauthorized action, highlighting the risk associated with such vulnerabilities in web applications. Now that we understand how the attack is delivered, so let's talk about how you can defend your application against CSRF. Nowadays, successfully finding and exploiting CSRF vulnerabilities often involves bypassing anti-CSRF measures deployed by the target website, the victim's browser, or both. The most common defenses you will encounter are as follows. First, CSRF tokens. A CSRF token is a unique, secret, and unpredictable value that is generated by the server-side application and shared with the client. When attempting to perform a sensitive action, such as submitting a form, the client must include the correct CSRF token in the request. This makes it very difficult for an attacker to construct a valid request on behalf of the victim. Next comes the same-site cookies. Same-site is a browser security mechanism that determines when a website's cookies are included in requests originating from other websites. As requests to perform sensitive actions typically require an authenticated session cookie, the appropriate same-site restrictions may prevent an attacker from triggering these actions cross-site. Next, referral-based validation. Some applications make use of HTTP referrer header to attempt to defend against CSRF attacks, normally by verifying that the request originated from the application's own domain. This is generally less effective than CSRF token validation. And with these defenses in place, your applications will be much better equipped to handle and prevent CSRF attacks. Alright, this brings us to the end of today's video on cross-site request forgery. We have covered the core concept of CSRF attacks, from understanding what they are to how they work and the potential risks they pose to web applications. We have also walked through how an attacker might construct and deliver a CSRF exploit, and importantly, we discussed the key defenses you can implement to protect your applications such as CSRF tokens, same site cookies, and referrer validation. So if you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. Do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Thank you and happy learning.